Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. I hope that you're doing well and you are ready for the program today. Because today on the show, we have the one, the only, Mr. Ralph Bond. We have a couple of stories lined up for you. All of them are going to be fun and really looking forward to talking about these. You may not have heard about them, which, is pretty easy to do. There's a lot of things to pay attention to, not always good, but I promise today's segment is going to be exactly that. It's going to be good and uplifting, so to use Ralph's words. So we'll bring Ralph on in just a second, but before we do, computeramerica.com. That's where you'll find everything, including past shows, future shows, all the shows, including links to all the articles, the show notes, the podcast. You can, of course, find videos and really anything that we talk about here on the program. ComputerAmerica.com will be the best place to go find out more about it. And of course, we'll have a link to Ralph's website and also to the playlist where, hey, if you want more Ralph, we got you covered. We got tons of it. So with that being said, let's go ahead and bring him on and just get started. So obviously, longtime Computer America correspondent, and all-around nice guy. You may remember him from the Intel Digital Minute, and of course, now it's WKEX with. Wow, my notes are completely failing in my brain. Mark Mason. Whoo, there we go. I got
That's it.
Ralph, welcome back onto the program. I got it.
Hey, it's great to be back, and today we have news ranging from moon dirt all the way to wood stronger than steel. So it's a real fun mix, to say the least. And to your point earlier, instead of the tragedy of the Ukraine and the scary stuff coming out of the committee meetings in Congress and all that, and the stock market today, and but wait, stop. We're going to lift your spirits. We're going to lift you up with science and technology news that's, like you said, goes under the radar a lot of times because of these busy news world we're in right now, but is promising, uplifting, and fun.
Definitely. And of course, all of these will have an application, maybe not today, maybe not tomorrow, but some of them definitely today and tomorrow. But all of these are really working towards making the future better. And that's what we really like about your segment, Ralph.
Yes.
So I think with that being said, why don't we go ahead and just start with story number one. We'll just jump right into it.
Yeah, and this is a great one for all of you like Ben, who are citizens of Florida. You should be very proud of this one. Anyway, the headline here is Scientists Grow the First Plants in Moon Dirt. And I picked this story up from sciencenews.com, and of course, many other outlets covered it as well. But here's the deal. NASA's upcoming plans to send astronauts back to the moon as part of its Artemis program has prompted a new effort to see if dirt brought back from the moon would be able to grow food and help support human occupation on the lunar surface. It's a big challenge. And it is a big challenge because moon dirt is basically, as one writer put it, a gardener's worst nightmare. It is not NOT, not full of the nitrogen, phosphorus, or much else plants need to grow. And it's also comprised of a fine powder of razor-sharp bits that are full of metallic iron rather than the oxidized metallic iron here on Earth that is palatable to plants. So it's got that problem. But wait, there's more problems. In addition, moon dirt is full of tiny glass shards forged by space rocks pelting the moon's surface. Okay. All right. So to find out if food plants could possibly, or plants at all, could be grown in moon dirt, researchers at the University of Florida in Gainesville recently planted thale, that's Thale, thale cress seeds in tiny pots that each held about a gram of dirt gathered by and brought back to Earth from the Apollo 11, 12, and 17 missions. And I'm going to add a little more about Thale crest because I certainly wasn't familiar with it. I went, okay, what's that? Well, the scientists love it, but here we go. Thale cress, or sometimes it's called mouse ear cress, is a small flowering plant native to Eurasia and Africa, and it's generally considered to be a weed found along the shoulders of roads and in disturbed land. I'm not quite sure what disturbed land is, but anyway. But you can eat the leaves in a salad. It just won't be much of an Epicurean experience, one writer says. And it's widely used for studying plant sciences, including genetics, evolution, population genetics, and plant development. So it's kind of one of the favorite little plants scientists use for testing and research. But with that said, on with the story. Miraculously, plants grew in all the pots of the lunar dirt. But reality check, no surprise, none of the test plants grew as well as those cultivated in Earth soil, and they didn't really expect that to be the case. However, and here's the payoff, however, a key finding of the research was that the test plants planted in moon dirt that came from areas with less exposure to the impact of space rocks and therefore containing far less growth inhibiting glass shards and metallic iron yielded the best results. And this discovery, Ben, the importance here is this discovery could guide future moon mission planners to choose a landing and occupation site with minimal such exposure to space rock impacts, giving growing food using moon dirt inside a controlled environment, of course, a better chance for success. So there's some real purpose behind this. Although I have to say, with the ability, there's one story I think we did recently where they talked about they were going to send 25 tons of material in advance of a moon landing in a module. I would just load that baby up with soil from the Earth. But not to squash the test here. It is just still kind of curious and fun and interesting to think that moon dirt miraculously could grow some plants.
So a couple things. First was the idea of disturbed Earth. I'm thinking that's let's say a forest is undisturbed. There's trees, there's undergrowth, there's vegetation, what have you. I think disturbed Earth is like let's say an empty plot in the middle of a city. There's Earth there, but it's very disturbed. It's been ripped up. It's been pulverized, and it's disturbed. So for everyone who did not see the pictures, we had pictures up, and we of course had the video as well, kind of playing. But this looks like any other concrete growing weed. Makes sense that they would use something that is very capable of growing in hostile environments. Ralph.
Hardy.
Very, very hardy. Very cool that they're able to do this. I would say, to your point, 25,000 tons or whatever it was of sending it to the moon. I think that maybe one of the goals, Ralph, would be to build some kind of hydroponic thing. If you can use moon dust and moon soil, and all you have to send is instead of 20 tons of dirt, you could send 1 ton of NPK and start your garden off. That would be much more efficient. Just send the minerals that the plants need and use the soil for
there you
soil.
go. Yeah, that's right. I think a kind of a compromise idea I think a 25-ton supply module was part of the idea of sending it to the moon's surface in a story we did recently.
Yeah.
And so what you could do is send amendments, send the phosphorus and so forth and the other things that the soil of the moon lacks, and amend the moon soil so you could have a kind of a compromise combo package.
and apparently you also have to send a roof because, wow, I did not know that, little tiny metal and glass shards were actually just pelting the moon all the time. That's news to me. But very, very cool. And then, this line right here where it starts off with miraculously, Ralph, I'll be honest, I did not think that you could grow anything in moon soil. The fact that, they're able to do it here on Earth, that is insane. It's further kind of gets the idea in your head that maybe there is life on other planets. It may not be trees and plants and forests and that kind of thing, but man, life can really grow anywhere. It's very, very impressive. So there you go. Story number 1. And I actually do love that story because it does further give you the idea that, hey, maybe a permanent moon base is possible.
Yeah.
That's perfect.
Yeah.
Story number 2, though, this is going to be, very, very good for anyone out there who's suffering, obviously, all types of cancer, because, I know it's not one cure fits all, but cancer research has been going on for so long it seems like we're still so far off, but any kind of breakthrough with any kind of cancer, always love to hear it. So, Ralph, story number 2.
This is a great one. It's so uplifting. And Ben, all the years we've worked together, medical science technology advancements are a big, big, important topic for me. And this one, gentlemen in the audience, men in the audience, pay attention. This is a good one. Here's the headline: Discovery of bacteria linked to prostate cancer hailed as potential breakthrough. And I picked this up from the United Kingdom's Guardian newspaper. And here's the story. Researchers led by the University of East Anglia in the United Kingdom recently performed sophisticated genetic tests on the urine and prostate tissue of more than 600 men with and without prostate cancer. Of course, that's what you always do with tests like this. And what they discovered, this is really fun. What they discovered is 5 species of bacteria linked to rapid progression of prostate cancer. And here's something that this will blow your mind. And 3 of the 5 bacteria were, prior to this study, unknown to scientists before this genetic research effort. Unknown. They discovered 3. Wow. And the men who had 1 or more of the bacteria species in their urine, prostate, or tumor tissue were 2.6 times more likely to see their early stage cancer progress to advanced disease than men who did not. And the genetic information on the bacteria microbes has led the team to develop half a dozen theories around how the bacteria could cause prostate cancer. And then, Ben, here's the really exciting news, the big payoff, if you want to call it that. The research team reported, quote, "If we can demonstrate that these newly identified bacteria can not only predict, but actually cause aggressive prostate cancer, for the first time, we may actually be able to prevent prostate cancer occurring." And as you always correctly point out, Ben, down the road, because this is the initial research, let's see how it gets implemented and deployed in the real world. But what an exciting, very optimistic beacon of light in the cancer research world.
Definitely. And you always need those. This one is really, really cool. And I'm glad that you picked it up, because I definitely didn't hear about that. One that I think people might have also heard about, this just happened a couple of days, like 2 or 3 days ago as well. Ralph, I don't know if you heard about it, where an experimental cancer drug had a 100% success rate in its trial.
Wow. I think I did hear something about that. I need to check that out.
Yeah. And that's not a story that, we may cover next week or something like that. But just real quick, that trial was a new type of drug, did something where it's a immune checkpoint inhibitor. That's the type of drug it was. And they had 29 people, Ralph. So very, very small sample size, very small study.
Right.
But in all 29, they had a 100% remission rate. So it was, it was very, very small, but I mean, I don't think I've ever heard of a 100% success rate.
Yeah, really that's incredible. Wild. And what kind of cancers? Was it a variety of cancers?
That one was colorectal cancer.
Yep. Okay. Well,
which is very hard to treat. So yeah, definitely. And I'll go ahead and send that link over to you. So maybe next week
we can do. Thank
definitely
you.
Do that.
Yes.
But yeah, perfect. And the fact that bacteria may be causing it. I mean, it's so interesting that we're still trying to figure out. Ralph, I'm sure that you know that cancer, when I learned it, was just random cells that were just mutating out of control.
Yeah.
Yeah, I had no idea that, maybe bacteria and obviously UV, like we're still finding out why these things happen. It's crazy.
It is bizarre.
Yeah. So there you go. That was very, very nice. Nice to imagine that, hey, if you're going in for prostate cancer, maybe an antibiotic might be in your future and give you a much better chance of success.
TBD. Yeah.
That's very, very cool. So story number 2. Story number 3. And this is a huge one because obviously we talk about the climate a lot here on the show. And one of the big parts is, of course, carbon dioxide. We're releasing a lot of it. We have to find a way to capture it. Ralph, we all can't just be buying carbon offsets everywhere else because, that's only going to get us so far. But this looks a lot more active and proactive. This is cool. So story number 3.
Yeah, and this story has a lot to do with the latest breakthrough, if you want to call it that, in carbon dioxide extraction or catcher machines that pull carbon dioxide out of the air. But anyway, here's the headline. New high-speed carbon dioxide catcher or system heralds new era in fight against climate change. I got this from Newsweek. Really, really interesting stuff. The more I learn about these carbon dioxide capturing systems, which are being developed all over the world, but this just happens to be the latest hot button news item in this field. So here we go. Researchers at Tokyo Metropolitan University have created what they claim is the world's fastest carbon dioxide capturing system, at least twice as fast as today's leading systems that pull carbon dioxide out of the air. And the research team says their new system, which could play a key role in the fight against climate change, uses isophorone in a liquid solid phase separation process that can remove carbon dioxide. Of course, that can remove carbon dioxide at the low concentrations contained in the atmosphere with 99% efficiency. Wow. And the Tokyo Metropolitan University research team claims their new system has the potential to not only help achieve net zero, but actually go beyond that. So here's a little refresher, a little reminder. Net zero refers to a state in which the amount of greenhouse gases going into the atmosphere is counterbalanced by the removal of the same amount out of the atmosphere. And so these researchers say, hey, this system could help us go beyond net zero, which would mean taking out more carbon dioxide from the atmosphere than we humans are putting in. Wouldn't that be a dream come true?
And really that gets us back down to pre-industrial, that gets us back down to something that's much more sustainable. And Ralph, I mean, this is kind of the goal because, for 100, 150, 200 years, we've really been adding and changing the atmosphere. So it's definitely cool to think that we can go the other way with it. We can affect the atmosphere, but maybe in a positive way. And positive, I really don't know what really benefits from having way too much carbon dioxide, but hopefully positive overall, hopefully no negative side effects. But fast is good because, we can use some expediency in tackling this issue.
Yeah, no kidding.
So there you go. Yeah. And I'm sorry, you may have covered it in the, in the article, but what are they going to do with it? In this little diagram that you have here, it looks like they kind of send it off to farms and stuff like that. I don't know if they use.
It's a great point.
I wonder what you do with all the carbon that you sequester.
Yeah, there are uses for it. And what you want to do is get the show notes. We talk about that at the beginning of the show. Please get the show notes, get the links. Go out there and dig deeper because there is a plan for the reuse of this captured carbon dioxide to be used to make things that could be helpful in agriculture and energy development and so forth. So it's just a wonderful kind of cycle of benefit. And check it out and learn, and also learn about other, in the UK, in Scandinavia, our country, France, Germany, and so forth. There's a lot of development around the world in this whole area of carbon dioxide capture. And again, this story was just where the Japanese were raising their hands and saying, hey, world, we've come up with something that we feel is twice as fast and could really boost this whole field of carbon dioxide capture. So there's a lot more to learn about it. And again, that brings up the point that what we do together every Friday, Ben, is highlights from these articles, kind of the condensed main points in a very friendly format. And if you want to dig deeper, please go out to computeramerica.com, get the show notes, get the links, and learn more if you want to.
Well said. I think between this and, saltwater desalination plants and stuff like that, Ralph, I think you've already done what you set out to do, which is you made me feel better about tomorrow and the day after. This is
yay.
Things are going to be okay, everyone. Things are going to be okay. But
if we just let scientists and technologists of goodwill, I have to qualify that, of goodwill, run the world, then yes, I agree.
They're in laboratories, locked in basements, eating pizza, doing what they need to do to make this world a better place. So, yes. But everyone, that was only story number 3. We still have story number 4, and this one is really, really cool because, we can talk real quick about a little bit about your background, Ralph, but when it comes to building, I think a lot of people still think cinder blocks, concrete, wood, timber, and it's as basic as it was. Maybe techniques got a little bit better, but materials are just as basic as they've ever been for 100 years. This next story kind of highlights there's advancements in every aspect of our society.
Yes. It is so true. And you're alluding to my years that I spent 10 years with Autodesk and all of the software they had for architecture and civil engineering, construction projects and so forth and so on. So I got deep into that world for 10 years and loved it. And what we're talking about here with this story, folks, the headline is Waste Wood Can Now Be Chemically Recycled to Produce a Material, wait for it, stronger than steel.
That's cool.
I got this from a great outlet called newscientist.com, a really good outlet. And if you have the show notes and if you're able to see it online here, you can see a picture of a dump where there's a bunch of construction wood scrap. And by the way, I'm sure most of our listeners have experienced this deal where you're seeing somebody doing a home remodeling project, or down the street here on the corner, around the corner, there was a house that tragically had a fire. And so they have been doing massive rework, and they had to strip the plywood off the roof. But it all went to a big bin on its way to the
There's
dump.
a lot of waste.
Terrible, huge amount of waste. So the first line in the notes here, millions of tons of scrap wood go into landfills each year. And the last government data I saw was from 2018, and it was just terrifying. In just our country alone, the amount of construction wood stuff that's just dumped. I mean, in the picture, you can see a little part of a roof structure there sticking out to the upper right. It's just tragic. All this could have a new life, and that's what this is all about. And by the way, on that topic earlier, I think back in maybe March, you and I talked about MIT, Massachusetts Institute of Technology, of course, had created a bone hard material made from wood waste, which is great. But now scientists at the University of British Columbia have invented a process to chemically recycle wood scraps to produce an even stronger super building material than what the MIT bunch came up with earlier this year. And the process they created dissolves lignin, that's lignin, which is a glue-like component inside wood cell walls. And dissolving lignin exposes cellulose nanofibrils, which are tiny fibers also found in wood cell walls. Now, the method involves a solvent called dimethylacetamide used in conjunction with lithium chloride. And I'm not a materials science guy, so I have to do more research to understand what that combination does for you. But when two pieces of wood treated in this way are brought together, that is, treated with this solvent, are brought together, the nanofibrils bind to create what the University of British Columbia researchers call a healed as in healing, healed piece of wood. I'm not quite sure why they picked that, but be that as it may. So although the new material no longer looks like natural wood, it is more resistant to breaking than stainless steel, or wait for it, titanium alloys. And across the street is a retired fellow who was in materials sciences. I was telling him about this story, and he said, stronger than stainless steel? Okay, that's nice. And then I said, or titanium alloys, and his eyes just went, he said, that is very significant. And the researchers noted, quote, we get a mechanical strength that supersedes the strength of the original material, of course, wood. It works because we use the inherent properties of cellulose, as did the MIT bunch, by the way, which is a material that binds together very strongly by something called hydrogen bonding. And there's a whole other area you can explore and learn about, which I'd like to do too. So here's the kind of end wonderful thing here. Not only can waste wood treated this way be reused to create new objects, again, stronger than steel and titanium alloys, but the treatment process can be performed repeatedly on the same pieces of treated, or as they would call it, healed wood, making it possible to recycle them indefinitely. So not only, oh my gosh, we can take waste wood, we can make this new material. It's great. 20, 30 years later, you demo a building made with this stuff, no problem. You can retreat it and reform it into other material. It's this endless, perfect recycle formula. I just I love this story.
Yeah, it really in my mind it kind of brings up the idea of like particle board, where you take a bunch of wood and you kind of blend it up, and you know, a lot of pressure, a lot of heat. But this is particle board on a cellular level, you know, and it creates something that's, you know, particle board is known for being cheap. If it gets wet, it's useless. It breaks easy. This is the opposite. This is, once it's treated, the stuff is stronger than what it was before. So hey, the new level of particle board, and it can do so much. Ralph, you of course with Autodesk, I am curious, and this is where people can go in the show notes and probably find the answer for me. But you know, they're saying that it's you know, kind of stronger. Of course, strength means different things: brittle, malleable, flexible, that kind of thing. Tensile
strength and so forth.
I'm curious, you know, kind of what they mean by stronger. But the fact that, hey, you know, we have a use for any of that, and especially in construction, that is very, very cool.
And you know what, Ben, you raised a good point a moment ago, and I wanted to find out more. Sure. That is with particle board or fabric. Like in the photograph in the lower left corner, you can see some scraps of the particle board, right? And what I don't know is, can this process work on that stuff? Because as you know, that stuff takes chips of wood and uses a glue and pressure and other things like that. Can this process be used on that stuff to create this new material? Or does it have to be like the 2x4s or the plywood sheets that you see in the pile of wood there? That's a good question I didn't have a chance to find out about. Hopefully the answer is yes. TBD. That would be, if it's yes, then particle board plus regular wood, if you want to call it that. If you could recycle all of that, how fabulous. And that's a little homework assignment, maybe, to find out a little bit more.
Absolutely. There you go. And fingers crossed there as well. But like you said, just being able to not just get better materials, but be able to actually reuse the materials that we already do.
Yes. Wow.
Construction is always one of those fields, and you worked in it for a while, that, you know, it's very, very interesting. There's so much going on.
Oh my gosh,
people should definitely pay attention to that as well. So,
go ahead.
Yeah,
Ben, if I may, I'll just add a little bit more to what you're just saying. And Autodesk and other companies in the world of construction and civil engineering, which you think is sleeper boring, wrong. Highly computerized, highly involved with all kinds of technologies. And there's something called building information modeling, which is just, if you want to learn more about the exciting, truly exciting world of building and civil engineering, just look up building information modeling. It'll blow your mind what's going on with computer software. And it's just one, and it's also contributing to much more efficient construction, reduction in waste, and so on and so forth. So check that out. That's a world you just blow you away.
it looks like The Sims, but on steroids.
Yes, there you go.
It is just
super steroids.
Yeah. It is just so complicated, and of course, all of that translates to the immediacy of the real world. So there's that.
There it is.
And you know, Ralph, I've actually found doing the show for so long, that's almost every field. Like there's something interesting. If you just dig a little deeper, there's always something there. And
so true.
Be that the environment, be that science, be that construction. Ralph, you do a great job of highlighting that for everyone there. So there you go. There's our stories. Everyone, if you want to find more information, go to computeramerica.com. We'll have the links. And Ralph, I want to thank you so much, and looking forward to next week as well.
Always a blast.
All right, everyone. So with that being said, we're going to go ahead and wrap it up. We'll catch you next time. Bye, everyone.